A healthy planet with its biogeochemical processes intact has this ability to buffer stress by absorbing more and more of the energy imbalance that we're causing. The drama is that we have more and more science showing cracks in the system.
Thank you to all of you for joining us today. Once again, from all over the world, you can see the stream on the signs. There's hellos and greetings, really literally from all over the world. And we're all here today because we are united by our common mission to make all of science open so that you as researchers, as scientists can work better together and deliver solutions that will enable all of us to live healthy lives on a healthy planet. And today's speaker represents this mission just beautifully. Johan Rockström is a global expert on sustainability science and one of the most cited researchers in the world. He's the director of the Potsdam Institute for Climate Impact Research and professor in Earth System Science at the University of Potsdam in Germany. Johan has received numerous international awards, and he acts as a strategic advisor to both governments and businesses across the world on sustainability issues. So Johan has pioneered the planetary boundaries framework. It was published the first time about 13 years ago, and since then it has become the standard for sustainability science. His book, Breaking Boundaries, The Science of Our Planet, has been actually made into a documentary with Sir David Attenborough, which I highly recommend to you to watch, for example, on Netflix. In his framework, Johan presented 9 planetary boundaries. They range from climate change to ocean acidification to the loss of biodiversity. And these 9 boundaries are fundamental in maintaining a safe operating space for humanity. So obviously his research has the goal to advance our knowledge of these 9 boundaries, but above all as well to keep us safe and to prevent us from crossing potentially irreversible and catastrophic tipping points. Because as we're gathered here today, global temperatures continue to rise and there is no sign of a slowdown. And the result of these of global warming are extreme weather events. And most recently, we have watched this catastrophic floodings in large areas of Pakistan, which affected more than 33 million people. So if we want to keep our Earth's operating space safe for ourselves, as well as for our children, then the science is clear. We must act now. And despite the many alarming statistics that Johan's research shows, he actually remains an optimist, and he will show us a path forward into the future in his talk today. So with this, it is my absolute great pleasure to now hand the floor to Johan. Johan, welcome.
What I'll be doing is to give you a scientific update on the challenges, and as Kamila says, also focusing on the exponential transformations for a safe landing for humanity on Earth, but also to start with the scientific journey that took us to the planetary boundaries, to walk through the evidence on the Anthropocene, to walk through the evidence of our dependence on the Holocene and on tipping point science, which together is the scientific justification behind defining a safe operating space for a stable and resilient Earth system. And it starts quite naturally with the proclamation quite recently by Antonio Guterres, the UN Secretary General, that we've come to a point of code red for humanity. I just want to kick off by saying that that statement, which is a very harsh statement, has today, unfortunately, full scientific support. But remember that Antonio Guterres made this statement on exactly what Kamila pointed out, on the climate extremes, on the frequency and severity of social and economic misery and impacts hitting us already at 1.2 degrees Celsius of warming. The reality is that we have actually more than one connected crisis that we're facing today. We've reached a point of turbulence. We are not only in the Anthropocene, the geological epoch we've entered in the 1950s, where we are now the dominating force of change on Earth, we are deep into the Anthropocene. We have a climate crisis, but we also have an ecological crisis that is undermining the resilience of the living biosphere to be able to cope with stresses like the climate crisis, which is manifested, for example, in zoonotic viral disease spillovers causing epidemics and pandemics like COVID-19. So here we have an example of a crisis, the health crisis that we've gone through for the past 2 years, hitting humans, but also the economy across the world, which is an example of something going wrong in one corner of the planet, sending invoices across the entire world with impacts on all of us. And then we have the geopolitical turbulence today with the illegal, completely devastating assault by Putin on Ukraine, which is sending signals across the entire global world order, distrust, and ramping up inability to really act collectively on the global commons and the global sustainability transition. So the starting point for this talk, unfortunately, is that we have challenges, and if anything, challenges that are exceeding even the position we were in when we signed the Paris Agreement 7 years ago. But let's kick off on the scientific journey. Well, it all starts with the Great Acceleration, the evidence of the exponential rise of the hockey sticks that we have learned to know. These are the two ones that we tend to focus all our attention to: carbon dioxide and population. The x-axis here is from the Industrial Revolution 1750 up until today, and you see that the curves bend in 1950. This is the case for essentially any parameter that you choose to look at that matters for human well-being, prosperity, equity, and social development. This is deforestation of tropical forests, which of course is driven by the GDP growth, which shows exactly the same bending. Loss of biodiversity, the curve that I personally perhaps am today most concerned about, the sixth mass extinction of species. The last one occurred 60 million years ago when an asteroid smashed out life of dinosaurs on planet Earth. The first extinction, by the way, caused by another species, us. Water use, the same with increasing use of materials. We have vehicles continuing to rise in the world, overexploitation of our oceans, ozone depletion, the only example of a planetary boundary where we actually bent the curve and are starting to stabilize back within a safe operating space. A good, one of the few success stories, and financial investments. If you look at this curve, what we now can conclude scientifically is that it is in the 1950s that we enter the Anthropocene. This is the takeoff point. It's 10 years after the Second World War. We're 3.5 billion people. We're put in the high gear of the industrial metabolism. And off we go and become the dominating force of change on planet Earth. We exceed the natural variability from orbital forcing of the sun, earthquakes, volcanic eruptions, all forms of storms and hurricanes. We amplify them, we dominate on Earth. But the reality is that, if for those of you who were part of that journey, it is in 1972 that the Limits to Growth is written by the MIT and Club of Rome. It is not until 1980s that we signed the Montreal Protocol on ozone depletion. It's 1992 that we build on the Brundtland Commission, which was published in 1987, and get the Rio Declaration in place, which gives the birth, by the way, to the United Nations Framework Convention and the COP meetings on climate, but also on biodiversity and desertification. More and more science indicates, and this is an hypothesis still, that it isn't until we reach the late 1980s, early 1990s, that we actually start hitting the ceiling of the capacity of the Earth system to buffer this great acceleration. What this tells us is that the Earth system has an inbuilt biogeochemical resilience to buffer stress up to a certain point. And we have more and more evidence of tipping points starting to occur and being observed somewhere late 80s with the flips in lake systems, ocean systems, anoxic events in many freshwater systems, accelerated ice melt, more and more changes occurring irreversibly and abrupt being documented in science from 1990s onwards. This is what we increasingly are understanding as a saturation point for humanity on Earth. That is one of the entry points to recognize that sustainability, which before 1990s, despite the fact that we were already in the Anthropocene, could be still kind of portrayed as us being a relatively small world on a big planet. There was still space for exploiting oceans, atmosphere, and biosphere. Well, but when we then transition into a saturation phase, we are transitioning into being a big world economy on a relatively small biophysical space, which of course is one argument why we need some form of guardrails to keep ourselves safe on the fragile planet. This is all translating into extreme events, as Kamila pointed out. Just to give two examples of this extreme summer we've had in 2022 with the war breaking out in Ukraine 24th of February, with rising fertilizer and energy pricing impacting food prices because Ukraine is one of the key exporters of grain. But not to forget that Prime Minister Modi temporarily shut export borders for grain because of a month of 40 degrees Celsius of heat wave over India, which led to so much drought and reductions in fresh water availability, impacting farmers. And we've gone through one more heat wave summer in Europe, and we have the Pakistan floods, we have the droughts in the Yangtze, we have the tremendous droughts in California and forest fires. We have the 4 consecutive years of drought in the Horn of Africa with massive starvation risks, all of this occurring at 1.2 degrees Celsius as extreme events. So the situation today is of a dual challenge. We have 2 challenges. One is the immediate one, which we're seeing at 1.2 degrees Celsius warming, undermining the biosphere resilience in the Earth system, hitting us with extreme events on the short term. And the important conclusion here is that this is not very surprising, given that we have reached the warmest temperature on Earth already today, since we left the last ice age 12,000 years ago. So this is not a small change that has occurred already today. But the second dimension here, the one that I will focus on in the next part of my talk, is the risks of undermining the state of the Earth system. Are we at risk of destabilizing the entire Earth system? Now, that question arises from the recognition of the extraordinary stability of the Earth system during the entire era when we've developed civilizations on Earth, the world as we know it. You've seen this curve. This is the ice core data over the last 20,000 years. You see on the y-axis global mean surface temperature. The 0 point is the pre-industrial 14 degrees Celsius point. We leave the last ice age 12,000 years ago, and we enter this extraordinarily stable Holocene epoch, the geological epoch we're now leaving, because you see the vertical line on the temperature rise on Earth. And what is so extraordinary with the Holocene are 3 insights. Insight number 1, that temperatures vary during the entire Holocene with only plus minus 0.5 degrees, 14 plus minus 0.5. So this is the proof that we've already crashed through that maximum temperature of this warm interglacial, because the Holocene is a warm interglacial. The second insight is that, we as humans have been around on Earth for 250,000 years at least. As modern humans, we've lived in deep ice age and had tremendous variability of temperatures and living conditions. And it isn't until we enter the Holocene that we transition over from hunters and gatherers to becoming sedentary farmers. This is the moment of the takeoff for modern civilizations as we know it. So the Holocene is the starting point for everything that we value as modern human beings in the world of the 21st century. And the third insight, which I'll be focusing a lot on, is the proof, the scientific proof that the Holocene is not some God-given stability. It's not as if the sun was just so gentle with us during this entire period. Oh no, we have more and more evidence that is the biogeochemical interactions and feedbacks, the resilience in the Earth system that has enabled the planet to remain within this very narrow corridor of life. So these are key insights, and we have the data going back to, in this case, 100,000 years, showing the last interglacial period, and another evidence of the extraordinary stability of these last 10,000 years, and all the proof that this is when we start our civilizational journey. Osman et al. Produced just in 2021 the most important synthesis, in a way, showing even more evidence of the extraordinary stability of the Holocene. We are now at the Potsdam Institute working on doing the same assessments for fresh water, for net primary production, showing, at least on the work that we are currently working on in our lab, that we have similar range of stability for basically these fundamental life support systems of nature and fresh water and temperature on Earth. So the conclusion is very direct and very dire. The Holocene is the only state of the planet that we can be certain can support the modern world as we know it. This is, of course, very concerning, given that we are exiting the Holocene and have entered the Anthropocene. On the other hand, it's very reassuring, and it's also very helpful because it gives us a benchmark. It gives us a measurable benchmark against which we can scientifically define a safe operating space. What does it take to have the Earth system in the state as we wish? When it comes to my second statement on the Holocene uniqueness, the proof is, one of the set of proofs is in this graph. This is the global carbon budget. You've probably seen this data showing above the x-axis, the y-axis here is gigatons of carbon per year. So this is the loading of carbon dioxide in the atmosphere. And the classic hockey stick above the x-axis, in gray, emissions from fossil fuels, and in orange, deforestation. Is it this curve, the cumulative volume under this curve, that remains in the atmosphere causing the warming of 1.2 degrees Celsius so far? Well, the answer is, as we know, no. It isn't, because in dark green, you have the uptake of carbon dioxide in the ocean, and in light green, in intact nature on land. So it's only the residual blue that has remained in the atmosphere so far, because the x-axis is from 1850 until today. This is extraordinary for two reasons. Number one is that it's 56% of our emissions, now concluded by the IPCC, being the number for the dark and light green, the world's largest subsidy to the world economy by far. But the second conclusion is, in my mind, even more humbling with regards to our relationship to planet Earth. Because just look at the graph. The more we stress the system, the more the system is helping us. So a healthy planet with its biogeochemical processes intact has this ability to buffer stress by absorbing more and more of the energy imbalance that we're causing. The drama is that we have more and more science showing cracks in the system, meaning that systems, large systems like the Amazon rainforest, is showing indications of losing its carbon stock and carbon sink capacity, which means that we are gradually showing signs of losing this ability of absorbing carbon. So this is why I am, and I hope I can say we are, really reassured and concerned with the IPCC AR6 conclusions to the left, that we are now unequivocally causing global warming, threatening human well-being, but also the state of the entire planet. But on the right-hand side, that actually safeguarding the biosphere's carbon stock and sink capacity is fundamental for us to have any chance of delivering on the Paris Agreement, meaning that it's not enough to just phase out fossil fuels. we also need to keep carbon stocks intact. But just to take this to the next level of scientific seriosity, meaning that the Paris Agreement is, as you know, to hold the global mean surface temperature well below 2 and aim for 1.5. Many have wrongly expressed this as being a compromise with low-lying island states, and it's a desirable target. We now have very strong scientific support that that is no longer the case. 1.5 is a real climate planetary boundary. In fact, Kamila, already in 2009, when we published the first planetary boundary paper, we put the safe boundary for climate at 1.3 degrees Celsius, equivalent to 350 ppm. But now we have so much scientific evidence that going beyond 1.5 shifts us from moderate risk level to high risk. And I'll show you the evidence for this. And we're following a path, as you know, that can take us to up to 3 degrees Celsius of warming by the end of this century, a place, by the way, we haven't seen for the entire Quaternary. I mean, you have to go beyond the 3 million year mark to come to that level of warming. But just a month back, we published the latest, and I would say a very comprehensive synthesis of the tipping element systems and the risks of tipping points in the Earth system, published in Science, led by David McKay et al. Here you have the key finding in that paper, 16 tipping element systems. The red embers diagram shows the scientific confidence range. On the y-axis, you have global mean surface temperature. We're looking for the temperatures at which science indicates that we're likely to push these systems across their tipping points. What does a tipping point mean? Well, it means a system shifts its feedbacks from dominating negative feedbacks, dampening feedbacks, to positive feedbacks, amplifying feedbacks, and the system changes irreversibly its dominant state. It can be abrupt, but it doesn't have to be abrupt. But it is, from our time horizon's perspective, irreversible. What you see here in the dotted lines, and I now put for the help to see this, the 1.5 degrees Celsius line, that 4 or so tipping element systems on average assessment in science are likely to cross their tipping points already at 1.5. So this is incredibly worrying that we have more and more scientific evidence that 1.5 is a real scientific threshold. It's a limit. Beyond it, we risk to trigger irreversible changes in large tipping element systems. What are tipping element systems, by the way? Well, these are the big biophysical systems that we know scientifically contribute to regulate the climate system, and they have multiple stable states separated by tipping points. Who are these for? Well, to the furthest left, you have the Greenland ice sheet, then the West Antarctic ice sheet. Together, they correspond to roughly 10 meters of global sea level rise. Tropical coral reef systems host to directly and indirectly some 500 million people across the world. Abrupt thawing of the boreal permafrost, the risks of losing even more methane and carbon irreversibly from the northern hemisphere. So we're talking big systems at risk already at 1.5. This gives tremendous scientific support for the Paris Agreement, but is also the science behind our let's say, the scientific guides we use to be able to define the safe boundary levels. When we're looking for planetary boundaries in a safe operating space, fundamentally, we don't want to rock the system out of its Holocene state, and it's the tipping elements that we have to keep on the right side of the fence, on the stable Holocene side of the fence. So this is incredibly helpful in determining the tipping elements. I just want to also pass through that we did publish before the synthesis a paper showing that many of these tipping element systems are interconnected, that we have today evidence not only that they're showing signs of approaching tipping points, but also, and let me just take you one example in particular, that the Arctic is proving more and more to be a ground zero for Earth system stability. The Greenland ice sheet melting fast, releasing cold fresh water into the North Atlantic, slowing down the AMOC, the overturning of heat in the North Atlantic, which pushes the monsoon system further to the south, which can explain droughts, fires, water scarcity over the Amazon. Another tipping element system, which then leads to more carbon into the atmosphere. but less warm saline surface water flowing up to the Gulf Stream in the North Atlantic means, of course, that you have more warm water stuck in the Southern Ocean, which can explain the accelerated melting of the West Antarctic ice sheet. So we have cascade risks and interconnectivity between tipping element systems. So overall, this is what is the scientific journey to planetary boundaries. We're in the Anthropocene. We're deep into the Anthropocene. The Holocene is our reference point for a desired planet, and tipping points are hardwired into the Earth system. Let me just make one little pause here to say that where is the light in the tunnel, which I'll come to? Well, a little light in the tunnel is that the Holocene is an equilibrium state of the Earth system. The Anthropocene is not yet, luckily, a new state. The fear is that it becomes a new state with feedbacks irreversibly pushing it, drifting off the Earth system unstoppably towards a new state. So far, the Anthropocene is predominantly a trajectory. It's a pressure point. It's the degree of human pressures on the system. So our task, of course, is to transform back into a safe operating space as fast as we ever can. The planetary boundaries, where we invited scientists across different disciplines to answer just two questions. What are the Earth system processes and systems that scientifically we know contribute to regulate the state of the Earth system? And question two, once we've identified these systems, we identified 9 systems, can we identify control variables and quantify a boundary level within which we have a high chance of keeping tipping element systems intact, but beyond which we risk triggering irreversible nonlinear changes? And the 2015 assessment, which you see here, showed that 4 of the 9 boundaries were outside of the safe space: climate, biodiversity, land system change, predominantly deforestation, and overloading of reactive nitrogen and phosphorus. Much science has been advancing since then, and we have particularly fantastic advancements in the freshwater boundary. I worked with this predominantly with one of the world's leading global hydrologists, Professor Malin Falkenmark, who introduced the whole concept of green and blue water and water scarcity index. Now we have the latest update when we can now show quantitatively the safe boundary for green water, the water in the root zone, and the vapor flows from biomass and from soils, the water that does not reach the blue water, the water in runoff and groundwater and lakes. And we can show through a paper led by Lan, Wang, Erlandsson et al. That we are beyond the safe boundary also on fresh water. There's also been really good advancements on chemicals. Another one of the boundaries that we were not able to quantify in 2015, what we call novel entities, the loading of all forms of microplastics, organic pollutants, endocrine disruptors, PFAS, nuclear waste, the whole cocktail of chemical accumulation. But in this paper by Lynn Persson et al., the conclusion is that we are outside of the safe space also on novel entities. So the indications are in the work that is ongoing right as we speak, because we have submitted the 3rd Planetary Boundary Science Update led by Professor Catherine Richardson at Copenhagen University. It's under review, but the indications are that we have now 6 of the 9 boundaries outside of the safe space, and that 4 of the boundaries that we identified in 2015 are also deeper into the red. And the evidence is really built on water regarding the deviation from Holocene stability, which is quite interesting. Increasingly, we're using data sets to have the Holocene as our reference point. But key here again, when moving into the final part of my talk, is that the Anthropocene is a new geological epoch, but it's not yet a new state. We can still, as far as science shows at least, avoid an irreversible drift away from a manageable state. We're exploring this very actively in the Earth Commission of how can we then choose a safe and just landing on Earth. We've been putting forward a lot of the evidence for the risks and pathways forward also in the 10 New Insights in Climate Science that we produce every year as a handover to the climate negotiators at the COP meetings. We are just finalizing the 2022 version of this, which will go to Sharm el-Sheikh. And the 2021 version show that, stabilizing at 1.5 requires transformative change. It requires following a pathway that requires, somewhere in the order of 2 gigatons of carbon reduction per year to have a net zero point by 2040, to have a high chance or a reasonable chance to hold the 1.5 degrees Celsius line. This translates to what we call the carbon law: cut emissions by half every decade, and we have a chance of having a net zero point by 2050 if we match it with the scaling also of negative emissions. I want to just put the finger on what this implies for nations in the world today. This is a Glasgow graph on the pledges put forward from countries. You see the US, the European Union, China. Look at China, that has decided to peak its emissions by 2030 and then reach zero by 2060. Too late for science, but just look at the pace of change this implies. Look at India, that has now put forward a net zero pathway to 2070. Much too late, according to the carbon budget allowance of 400 gigatons of carbon dioxide remaining, but still it is transformative. Now, countries unfortunately have pledged but not delivered, but it just shows that we're in for a very, very steep journey. Is it possible to achieve? Well, there are so many initiatives out there, from Project Drawdown to what you see on this screen here, which is the exponential roadmap, the 1.5 degrees Celsius business playbook, which now gathers many, many hundred companies, showing, wedge by wedge, sector by sector, with the existing technologies that the answer is yes, it is possible to cut emissions by half in the global economy across sectors by 2030 and continue that path. That's quite interesting, that we have more and more evidence that the scalability of renewable energy systems and circular business models and being more efficient with resource use is actually something that can deliver both on the scientific requirements, but also give better economic performance in the other end. And just here, the latest update, sector by sector, just showing even at quantitative levels of carbon dioxide equivalents that can be sequestered with different zero carbon investments. So basically, and this is just to give you one more really key part of this, which is that the carbon law, which I just described, is really only on reducing emissions in the fossil fuel-based sector, oil, coal, and natural gas. At the New York Climate Week, 3 weeks ago, we also presented, together with Conservation International, the carbon law for nature and the exponential roadmap of transitioning managed nature. So the challenge we have is that we need to keep intact nature intact. All the carbon sinks in standing natural ecosystems, rainforests, temperate forests, wetlands, all forms of permafrost. But we also need to transition managed nature, managed forests, agriculture from source today to sink. And we have the carbon law for nature of turning nature from being a net emitter, today emitting 11 gigatons of carbon per year, carbon dioxide per year, to reach a level of net zero by 2030, and then starting to be a net sink by 2040 and 2050. And again, not based on fantasy, but based on existing technologies, from agroforestry to conservation agriculture to crop rotations to much better perennial grain systems, for example. This is quite exciting. We've had several dialogues at the World Economic Forum with the recognition that we are, probably quite deep into the fourth industrial revolution, the digital and biotechnological scaling of new innovations. I argue that we need to cap this innovation path within planetary boundaries, and that an hypothesis is that this can unleash even more innovation, because when you constrain top engineers and systems thinkers with even more challenging constraints, this can rather amplify the degree of transformative ideas. And this is why we had 1 month ago a major conference, the first conference ever, that we co-hosted between Exeter University, Tim Lenton, and ourselves at the Potsdam Institute on tipping point science, not only the risk-based tipping points, but also the positive tipping points. How do we unleash, what are the levers to unleash exponential journeys in the right direction if we now have been spending the last 70 years to move exponentially in the wrong direction? And quite interestingly, you see more and more empirical evidence that in populations, you always have the innovators and the laggards in the extreme part of the population, but then you have the indifferent majorities that are today showing very, very clearly an engagement and understanding and concern over climate crisis, but they're not willing to go to the barricades to act on this. How do we make the indifferent majorities to step on board sustainable changes? And there are a lot of ideas here, looking at keystone actors, proving more and more on benefits for sustainable solutions, subsidizing pioneers to be able to scale solutions. And the big challenge we have is to combine enabling conditions, which can include policies, capacity development institutions, with individuals in society to be able to get a large enough minority of first movers to tip over the logic also for the indifferent majority and make the sustainability journey more or less unstoppable as we see a trend line of negative trends also risking to be unstoppable. So basically, to close this, scientifically, we're doing everything we can to help businesses, cities, communities, countries to set scientifically based, safe and just targets for a stable and resilient Earth system. This is what I would call the new dimension of Earth system justice, to hand over to our children and to fellow citizens the ability of having a planet that can continue supporting human development and be as close as possible to a Holocene-like manageable state. That is where we've come to, and that's where I would argue that the sustainability agenda is at, and that we need to push this final hurdle of getting us on an unstoppable journey in the right direction and avoid falling back now during this turbulent phase towards losing ground, because we have made quite some progress over the past 5 to 10 years. And now is the question of accelerating this. So this kind of engagement here is really valuable in that sense. And I look forward to a panel and discussion on this. Thank you very much.
You've made it perfectly clear that this is the most important challenge that we face as a society. I don't think there can be any doubt about that, and how it touches upon virtually every aspect of our lives as individuals and as a society. I have one question before I move to the panelists. I'm just wondering, you talk about the 4 or the 6 boundaries that have already been transgressed or that are under threat. When you first conceptualized this planetary boundary framework in 2009, if you think back to that point in time, did you ever imagine that we would find ourselves in this situation so quickly?
Yeah, thanks, Fred. Yeah, that's a really important question. I mean, already in 2009, when we put all the evidence together from the Anthropocene, the Holocene, tipping points, and inviting scholars from, oceanography, climate science, ecology, agriculture, of course, the indications were very quickly that we were very likely to come to result that we had transgressed several of the boundaries. But I must admit that I was surprised to see the depth by which we are in the red on nitrogen and phosphorus. Fresh water, we concluded, was actually in the safe side in the first assessments, and now it's proven to move quickly in the wrong direction. This is also an effect of the interactions between mismanagement, degradation, deforestation, and climate change. So yes, it happens faster than I had expected. But so it's a mixed answer, actually. On the one hand, no, it isn't such a big surprise that we were outside of the safe space, but that we have the large number and that it's so far outside of the Holocene range is deeply concerning, and perhaps even a bit unexpected, particularly in the beginning. And I haven't talked about the only boundary that was out in the red but came back in, which is ozone depletion. So of course, we should talk more of that potentially, that there has been one boundary that went deep into the red, but also we were able to act on listening to science and acting.
Thanks, Johan. I think what we're going to do is move very quickly now to the panelists. Make sure everyone has their time to add their perspective. So today we're very lucky to have three high-level panelists. We have Professor Peng Gong, who is the chair professor of global sustainability at the University of Hong Kong, where he is also vice president and pro-vice chancellor of academic development. Our second panelist is Felix Dapare, who trained as a plant biologist and is now the current president of the African Academy of Sciences. And our third contribution will be from Phoebe Koundouri, who is a professor at Athens University of Economics and Business in Greece. Phoebe is also the field chief editor for Frontiers in Environmental Economics. So I'm going to start by asking a question to Peng to kind of frame the discussion. Peng, one of the key focal points of your research is the mapping and monitoring of global environmental change. So could you please let us know a little bit about how remote sensing fits into the planetary boundary framework, the role it plays in that framework, and maybe even a little bit about what you've already seen in this context?
Thank you very much, Fred. Before I start, I want to just say a few words about my feeling after listening to Johan's talk. First of all, that I've been a close follower of the planetary boundary concept and also the framework. And I really think it's an excellent framework for the scientific community to actually develop solutions to address today's global change and climate change issues we're facing. And of course, environmental change is also a bigger aspect. And after listening to Johan's presentation, it's fascinating. We see how during the Holocene and also through the Anthropocene, how great we achieved. Our population increases, our life expectancy is increasing, lots of good things, but at the price of sacrificing our environment. And technology helped us to get to this stage. I think the solution is also science and technology. We need to further develop to solve our problems that we created for our environmental issues. So those are the two points that I want to make. So in terms, coming back to your question about my involvement, I have very little, contribution in terms of doing global land cover mapping and tracking land cover and land use change, particularly, water bodies in terms of their quantity, volume, area, their change. So I've been working hard trying to make relatively more frequent monitoring of some of the surface cover types. Obviously, that's only one part of what Johan has laid out. There are 9 planetary boundaries. The field of remote sensing can actually contribute either directly or indirectly to the understanding of the status of our planetary boundaries. Take climate change as an example. We now have relatively frequent, twice a day, or 3 or 4 times a day measurement of surface temperature, atmospheric temperature, precipitation, and also you can even measure some of the atmospheric constituents. In the planetary boundary, atmospheric aerosols is one example, ozone, carbon dioxide. All of this can actually be measured by sensors mounted on satellites. So, but their frequency are limited. So we can imagine that if we want to have hourly or every half an hour or even more frequent measurement or the status of the Earth, most of satellite cannot do it.
Mhm.
So that's actually, either there's hope that that technology need to be further advanced. It may not really be so helpful for us to launch so many satellites into the space. We know that they bring us, it's double sword also. They bring us some information, they also become, some of the hazard in the space for our, safe use of the space. I only mentioned, atmospheric aerosols, ozone, and actually, some of the land monitoring satellite is very useful in the land system change, which is another dimension of the planetary boundaries. This is where that I work a lot. For example, we map, we develop, we integrate, fuse, and model satellite data so that even the satellite cannot see a particular area, we simulate satellite data. So we created a artificial constellation of satellites that produce data on a daily basis. This is something that recently we worked out. So we produced a 36-year data record of land surface at 30-meter resolution for anywhere on Earth that is land. We will be able to have daily reflectance measurement at a specific time in the day.
Thank you, Peng. I think that type of data, I think, will be important in terms of making sure that there's a certain amount of compliance around the way that that we move forward with managing these planetary boundaries. And what I'm going to do is I'm going to move forward to our next panelist to hope that we have a little bit of time for interaction towards the end of the program. Felix, it's over to you. And I think, we talked a little bit about how complicated, how complex the context is around these planetary boundaries. And I think we all know that African ecology is unique in many ways, the African environmental context. What do you think we need to keep in mind about Africa specifically when we talk about this planetary boundary framework?
Thank you very much, Fred, and thanks, Johan, for a brilliant talk, as well as my colleague, Peng. Let me start by saying that although Africa has contributed very little to global warming, it stands to suffer the most from the negative effects of climate change. And if you talk about African ecology, it's extremely fragile, especially its negative effect on the fauna, flora, and indeed the soil health of the African continent. Let me start by saying that Africa has 4 major deserts. And of course, desertification is a major issue around climate change. We have the Sahara Desert, we have the Nubian Desert, we have the Kalahari Desert, and we have the Namib Desert. So in essence, whatever we do in Africa, we have to keep in mind the impact of these deserts on redeeming, the climate change situation. And the other thing that's unique, which I always say, very unique to Africa only, is the oldest continent on the planet. It therefore has the oldest soils, which are extremely nutrient poor. Indeed, as a result of that, even without climate change, we've got something like 263 million Africans who are suffering from protein-calorie malnutrition, for the simple reason that the nutrients that are in soils are extremely low. And the macronutrients are even much lower. So you get something like 269 million Africans who are suffering from trace element deficiency, such as iron, selenium, zinc, and name it. Now, these are extremely unique to the African continent, and it's only Africans and African scientists who must start to think about some of these problems. What I'm saying is that if climate change continues with the rise in carbon dioxide, we are going to get more and more nutrient deficient foods, and that will only further promote health problems, whether it's macronutrient deficiency or it is protein-calorie malnutrition. Additionally, what is there, I mean, the science has the evidence that with rising carbon dioxide in the atmosphere, many more crop species are taking in less and less of nutrients in the soil, even where the soils are rich. There is dilution of these nutrients by, photosynthesis that the plants make. And so again, compared to other continents on the planet, Africa stands to suffer the most. And if we go on to that, because of these deserts and the nature of the ecology of the African environment, we tend to get a lot of droughts, as Johan just mentioned. We've had prolonged drought in the Horn of Africa, which has led to profound food and nutritional deficiency problems. Essentially, with a lot of people now tending to be more dependent on food aid that can come from outside. So Africa is therefore very prone to some of the hazards of the environment. And of course, the other extreme end is drought, where you see that, it's flooding, the opposite of drought. But more importantly, another unique challenge to African food and nutritional security caused by climate change is the perennial effect of the desert locust. It's a form of grasshopper, and when you have climate change, some years you get an outbreak, and when you get outbreak of the desert locust, there is devastation of all forms of vegetation, including what you may call a pasture for livestock, leading to, again, food and nutritional deficiency, as well as loss of quality food. So here again, it's unique to Africa. You don't get it in the other continents. And so it's a problem that the African people must solve. Africa also is prone to the malaria disease caused by mosquitoes. Any rise in temperature leads to rapid multiplication of the mosquitoes and a rise in malaria, which is also a very dilapidating and leads to ill health, as well as decrease in productivity, whether it is at farm level or it's at the level of the office. So from that perspective, actually Africa stands to lose a lot in the context of climate change. The good news is that at least I'm very personally happy to see that the African Union has established this, the Great Green Wall of Africa, which starts from the north of Senegal and cuts across to the Horn of Africa. Now, the Great Green Wall of Africa is doing very well. All what we'll need is input of resources, financial infusion of financial resources for us to study that Great Wall of Africa, understand it better. Currently, there's growing vegetation in the paths that are well established, which leads to carbon sequestration. There's a return of life to what was previously a desert. And so with time, I strongly believe, I'm positive, that with such inputs, as Johan was saying, we can probably push back some of the negative effects of the Sahara Desert. And if you can type of programs with the other three deserts, whether it's Namib Desert, Kalahari, or the Nubian Desert, I think they will become a source of carbon stock. You actually can change the macro environment itself, which will lead to much more improved rainfall and food security that will provide jobs, as well as vegetation for livestock and what have you. So there are many, many positive effects if we can go back to nature-based simple solutions. The hardcore ones are there, but I'm talking of things that the ordinary man or woman in Africa can do to make their contribution towards arresting the effect of climate change. Perfect.
Well, Felix, thank you very, very much. It's again, the complexity of the issue comes out, and the impact that it has on society at every level, down from the individual right up to to collective action, and the potential positive collective action from coordinated efforts within Africa. So thank you very much. We're going to go now to our third panelist. Phoebe, I think you're here. What I'm going to do, what I'm going to do is, what I'm going to ask you to comment on. are, you know, the economic implications, the financial, the social, the economic implications. Everything seems to be interconnected here, you know. And so, what do you think, from your work? What do you think the priority should be at that level, the financial, social, economic level, to remain within, or to even to restore these planetary boundaries?
Yes, it was a great lecture by Johan, and indeed we are facing tipping points, and indeed we are facing deep uncertainty with regards to these tipping points. The good news is that we have an agenda that has been signed by 193 countries. It's the Agenda 2030 of the UN, which basically is our blueprint on how we move away from the tipping points and how we can get on a sustainable pathway. So 17 goals, 169 targets, a very systemic, integrated, interdisciplinary, science-driven and science-hectic and data-hectic framework, but we have our blueprint and we have agreed to that. So if we look, let me give you some, very briefly, some results from my work, which basically puts together the work of 5 different research institutions that I lead, or call it 4 innovation accelerators. As Johan said, innovation acceleration is crucial, but also capitalizes on the world network of the United Nations Sustainable Development Solutions Network that I lead, the Global Climate Hub and the European Hub, and the European Association of Environmental Resource Economies, the biggest association in the world of economies dealing with the environment and planetary boundaries. And I have the honor to be the president of that society. So basically what we did, we took the European framework, which is supposed to be a leading framework, and I'm referring to the European Green Deal and the associated policies, the digital policy, the industrial policy that tries to set us on a pathway that is sustainable. And we try to see whether this framework really is consistent and compatible with the SDGs. And what we find when we cross-compare the European Green Deal, which mainly tries for climate neutrality by 2050, zero pollution, clean tech leadership of European companies, and leaving no one behind, social cohesion. When we cross-map with machine learning methodologies, all the hundreds of thousands of patients of European laws that try to accelerate this transition, because as you've said, we need to accelerate the transformation that will allow us to get on a sustainable boundary. We find that the European Green Deal is quite efficient with regards to getting us on a pathway that is relevant for decarbonization and sustainable land, water, seas, and ocean use, but is less efficient and quite worrying so in allowing social cohesion. And that's why socioeconomics is crucial in this transition. Without social cohesion, you cannot achieve any transformation. And we need, as we announced at the UN General Assembly, as Sustainable Development Solutions Network, we need to focus the operationalization of the SDGs in 6 transformations. We need social cohesion, so we need a transformation on well-being and health. We need a transformation on education and equality, another on decarbonization, another on sustainable land use, sustainable use of oceans and water. the digital revolution for sustainability, and of course, sustainable cities and communities. These 6 transformations are the transformations that can operationalize the SDG, and they actually refer to ministries in most of the governmental structures of nations around the world. So we need to be very focused on understanding the systemic framework of the SDGs, focus on the 6 transformations that operationalize them. And when you go to the economy, then you need to be very accurate in valuing and monetizing natural capital and human capital. We've been producing the last centuries of our lives by focusing on the cost of produced capital, but in order to produce any production, any good or service, you need produced capital, natural capital, and human capital. And produced capital is easy to have its value because it's traded in markets, but natural capital and human capital are not traded in markets because the ownership rights are not explicit. As a result, the value of this capital goes unrecognized. However, we present evidence that the biggest value of any production consumption activity is assigned, is relevant to natural capital and human capital. So we've done a big exercise in order to value natural capital, cultural capital, and human capital, and integrate this in our cost benefit and policy decisions. So the SDGs need to be perceived as a blueprint for identifying an investment program for each and every nation, which will be assessed by taking into account the cost and benefit that all forms of capital that we are using are bringing us, and monetize these costs and benefits. And when you do so, it becomes very explicit how to use the planet, and it becomes very explicit how you can get back to a sustainable pathway. And you can also be very vigilant with regards with what kind of discount rate you are using, because the constant discount rate is not relevant for long-run projects. We have done a lot of work on estimating time declining discount rates for long-run projects. And you also need to be very vigilant with regards to the regressive effects of your climate policies or biodiversity policies, of energy policies, food policies, and all that, because we know that there are going to be regressive effects, and we have to create a package of measures that can mitigate these regressive effects on the vulnerables. And we can also show, and we also showcase in general equilibrium analysis, that it is quite possible with lump sum transfers and lowering VAT and targeted energy efficiency measures and job retraining programs and subsidies for low carbon, you can actually achieve higher GDP, higher employment, more equality, and at the same time, you can achieve your climate goals. Let me close by saying that it is important to integrate not just in national planning, but also in company planning and financial institution plannings. The SDGs. You have to allow the business plans to be transformed in order to integrate the value of nature, the value of human capital, the value of cultural capital, and you need to allow them to integrate the perfect storm of the policy framework that is changing fast enough so that they can become profitable while transforming to become sustainable. And we show for European companies now that those who transform faster and adopt innovation faster are the ones that can remain profitable when new regulations, climate, biodiversity regulations come in. For this reason, we have recently established the Global Climate Hub of the United Nations Sustainable Development Solution Network, which I chair. And our mission there is to provide free support for governments, but also companies and financial institutions in order to identify the optimal mixture of technologies, policies, and financial instruments that will allow them to detail their pathways to sustainability. Thank you for your patience.
Phoebe, thank you very much. Your passion and your optimism comes through very, very strongly. And I think, the comments, the general comments that you made actually fit very, very nicely with Felix's comments too, which were more sort of focused on a regional aspect. And the importance of social cohesion is something also I think that we should that needs to be emphasized. And as Johan said at the beginning of the presentation, in the context of COVID and the war in Ukraine, social cohesion becomes even more difficult to achieve. I would say, it's our tradition to ask one or two people to come up for a question at the end. And so what we're going to do is I'm going to open up the discussion. If you're called on to ask your question, please remember to say who you are, where you're from, and keep your question brief so that can really be the starting point of a discussion. The first question, it will be by Nena Rončević. Nena, are you still with us? Can you?
Yes, I'm with you. Thank you.
Hello, Nena.
Hello. So my name is Nena Rončević. I'm an associate professor from the University of Rijeka in Croatia. And thank you very much for the opportunity to have a question. I thank Professor Rockström for his great presentation and all the panelists for their comments. So my question is really broad and philosophical in its nature, but nevertheless, what is the role of social sciences, humanities, and education overall in sustainability transition? So that's my question. Thank you.
So Johan, I don't know if you'd like to start.
Yeah, I can start. So yeah, so thanks Nena. Well, the simple answer is that the social sciences, humanities plays a fundamentally important role. Actually, in the Earth Commission that I co-chair together with social scientist Joyita Gupta, professor at the Amsterdam University, but also Professor Qin Dahe, glaciologist from China, we are integrating social sciences and physical sciences to set up the safe and just and justice in terms of harm and access rights to the safe operating space. So, of course, there's no doubt that the only way to really unleash a transformation and accelerate the pace towards sustainability, where I, by the way, fully agree with Phoebe and the assessment that we have more and more empirical evidence that sustainability gives better outcomes, both economically and socially, is in the area of the social sciences to not only help us with the behavioral change, but also to give what I would call the quantitative evidence of the benefits and the better security and health outcomes of a transition to sustainability. However, just to close this, I think that a challenge we have is that the social sciences need to align or dig themselves deeper into the natural sciences to really understand the Anthropocene, understand the tipping points, understand nonlinearities, not continue believing that sustainability is this incremental sustainable development agenda defined in the 1990s. It's we in the natural sciences have to be much better at engaging with social sciences, but it has to also be vice versa. So I think interdisciplinarity is key.
Yeah. Can I say something very quickly?
Of course.
I fully agree, interdisciplinarity, but true interdisciplinarity is key. We need to understand each other and co-create models that are relevant for the crucial issues. And one crucial issue is ambiguity. We don't really know the probabilities of a certain event lying in the future, and much less with regards to the social events that can lie in the future. So I would say true interdisciplinarity, technical integration of natural sciences and social sciences is crucial to make the models consistent. I spent lots of my life on this, and it's not easy. But let me also say that for such a big transition to take place in such a short time, we really need to engage all the stakeholders, and all the stakeholders are the politicians, the policymakers, the businesses, the financial institutions, the civil society. They need to be engaged, and in order to be engaged, they need to understand the problem. There is no deep understanding of the problem. They need to understand that solutions exist, and they need to co-design the solution pathways. That is, they need to take part in the way that we are going to design our way towards sustainability and become shareholders of the main projects. And of course, together with this, the governments, but also public partnerships, public-private partnerships, because all the public money in the world is not enough for such a huge transformation, public-private partnerships for upskilling and reskilling, so that the unprecedented technological advancement can be really adopted in the market.
Mm-hmm. Thank you, Phoebe. We're going to take one more question, and I think this is a question that was inspired from Felix's comments. Marvin Bachmann, are you still with us, Marvin? And would you like to ask your question, please?
Yes, I am. First of all,
who you are, where you're from, quickly.
Thank you for the interesting presentation. My name is Marvin Bachmann. I'm from the Chair of Technical Thermodynamics in Aachen. And we currently applied the planetary boundaries to a global assessment of the plastics industry. And therefore, in order to assess if the transition of the plastics industry can also be absolutely environmentally sustainable, we applied downscaling. And I was wondering on your insights on downscaling in general, or broadly speaking, what would you do to incorporate the planetary boundaries in sub-global decision-making?
Yeah, thanks, Marna. So this is really challenging, as you know, and you're working on it. And I should start by saying that the planetary boundary science, as such, does not integrate scaling methodologies. We are working on scaling methodologies, though, in the Earth Commission, looking at how to translate global boundaries to different sectors, different geographies at national level, and looking at different approaches to that. And everything is, as you know, not only boundary specific, but very much sector and often socially specific as well. I mean, the challenge of differentiating between different responsibilities, both historic but also capability-wise. So I would like to follow up on this bilaterally, rather, because I think it's too easy to say that you take a carbon or a budget, a finite budget of a planetary boundary, and then scale it at a per capita level, because I think that does not take us all the way, particularly not on chemical pollution or on plastics pollution. I think it must be a much more value chain based methodology. So I divert that to a follow-up.
Thank you, Johan. I don't know if Felix or Peng, if you'd like to add a word on this idea of sub-global decision making. I think Felix, that's probably something very, very close to your heart.
Right. Would I make 2 cents also? I think that today, with social data, we need to harness the society in local, open social big data. And that will help us to collect data in different areas. And like what Johan is saying, that different people with different culture, different habit in different location will have different outcome. So in one region, we do it, we need to share and do it, share the experience and respect the differences and develop methods to address the differences. And I think we are able to. reach both accurately locally and also globally, through a combination of methods.
Thank you, Peng. Felix, would you like to have the last word?
Thank you very much. Yeah, I just want to say that if you take the African situation, if I may again localize our problem, we really have, we're struggling to deal with waste in general, but especially plastic waste, to the extent that, we are not we're not converting them into anything at this point in time, but there are policy directions that is preventing the abuse of the environment by how much plastic is thrown around, including other forms of waste. And because of that situation that we've not addressed it scientifically, it's actually become also another element of climate change challenge, that we've got a lot of waste material, you could call it dumps, across the continent. We probably have up to about 9 major dumps out of probably 15 in the world. That pose a serious challenge to human health in terms of emissions that are coming out of there when there's degradation, in terms of poor hygiene, where human pathogens can infect human beings, especially children playing on those dumps. So yes, in relation to upscaling, I hear what Johanna said, but in terms of dealing with it at a lower level, perhaps not internationally, but at local systems such as NAFTA, there is room for any technology that's been developed to address the use of plastics and other waste to be upscaled, that can benefit communities that don't have the means of actually processing waste materials into something more valuable. So I think there is room for that, at least within the African continent. Thank you.
Thank you, Felix. And so with that, I think we're going to close today's presentation. Thank you, everyone, and a special thanks to the Frontiers team that supported us today to make it all happen. I'd like to also thank our speaker, Johan Rockström, as well as Peng Gong, Felix Dakora, and Phoebe Koundouri, and everybody else who contributed to the questions. And thank you for everybody who attended. I hope you enjoyed the session. We look forward to seeing you at the next Frontiers Forum session, which will be on Tuesday, 29th of October, where we'll hear from Ove Goldberg about the future of coral reefs. And this is something that was touched upon briefly as one of the aspects in Johan's talk. A reminder, you can continue the conversation about today's session on social media using the hashtag Frontiers Forum. And so until we gather again for the next forum, a warm goodbye to each and every one of you. Thank you very much.
Thank you, Johan. Really fantastic session. Beautiful presentation. Depressing topic, but it seems that there is hope for the future, and there is still so many things, in fact, that we can do, and we're just getting started. Thank you so much.
Thank you very much.
Thank you very much.
Thanks also for fantastic talk.
Thank you.
Goodbye. Fantastic talk. Thank you so much.
Thanks.
Thank you.
Thank you. Have a nice day.